Right, hello everyone. For those of you who don't know me, I'm Pete Savage, and I'm going to be talking today about how to build simple GUI applications using Python, Glade and GTK. So these are the topics that I'm thinking about covering at the moment. Is why use Python, the concepts behind the GUI application, how does it actually interact with the user, the tools that we're going to use, a simple example, how we can extend that example into a more advanced application, the resources that we can find available on the net and in other places, and finally your questions at the end. So to begin with, why would you think of using Python to develop a GUI application? Well, the main reason I would say is it's very, very easy to learn. I've really only been using Python since about August. And I'd created my first GUI application in about 2 weeks. So it's a fantastic language to be able to pick up and use. It promotes clean and readable code from my experience. Python does something which other languages, or some other languages, don't, in that the blocks of code have to be separated with white space, which I'll show you later on, which means that you have to indent your code properly in order for it to work properly. It's cross-platform, so it can work on both Linux and Windows. It's a fantastic rapid application development environment, and there is some great documentation out there, especially for the GTK and the Glade side of things. So let's talk about the concepts now and what we're actually trying to achieve. This is a dialog box which you'll all be familiar with. And we need to come up with some of the terminology that's used when we're developing these GUI applications. So we're going to take a simple button and we're going to talk about what happens when that button is clicked. Well, the first thing that happens is a signal is generated. And in this case, the signal is the clicked signal. With other different things like buttons, drop-down menus, there are different signals that can be sent out, so that when you hover over a button, it might send out a different signal. But in our case, we're going to take the clicked signal. When that's pressed and when that signal is generated, that then gets passed to what we call the handler. And the handler then performs the action which needs to be done once that button has been pressed. So the tools that we're going to use in this example, most of which, if you use Ubuntu, are going to be pre-installed. I'm not too sure about most of the others, but most of them will have Python, Glade and GTK on there. The only one they won't have is the actual Glade development portion of it. So what does Python do for us? Well, it ties everything together in this jigsaw of building a GUI application. Glade allows us to design the graphical user interface. You can do it all by hand. You can hand code all of the widgets, as we call them, and connect them all up with signals by yourself. And in some cases that's easier to do. But when you're building a large application, having something like Glade to help design the GUI is a really good resource. And as we'll see later on, it sets up signals with what we call references. And these references are then used later on to turn them into the handlers. PyGTK, which is the binding between Python and the GTK toolkit. The GTK toolkit is what draws all of your buttons, all of your drop-down menus, all of these types of things. It draws the windows, everything, and you don't have to worry about any of it. With GTK, you basically just say, draw me a window, and it will draw the window. You say, draw me a button now, and it will put a button in there. And it sets up all of the signals that can be passed with these widgets for you. So the advantages, as I say, of using Glade is it's fantastic and very easy to create a complex graphical user interface. With putting things like tabs on pages and various other bits and pieces, it really is a good resource. And it handles these linking of signals to handlers via what they call a dictionary. When you do it manually, when you sort out the widgets and the handlers manually, you will say, connect this signal to this function. When you use Glade, you kind of have an intermediary in the middle. And so you say, this signal should use this reference. And then when we get into Python, we say this reference refers to this handler. Okay, and we'll go through that with an example. A downside, I suppose, is it can produce largish files. It uses an XML structure to design the GUI and to import into Python, but this can sometimes be fairly large when you've only really put a few buttons on a page. So this is what Glade looks like, and in a second I'm going to go through and design a simple GUI so that we can see how it works. But the basic portions you have are the toolbox, which is where you decide what widget you need to place onto a page. Your properties panel, which is where you set up which signals refer to which reference. Your project window, this is good because it has a nice tree structure, which we'll see later, which displays all your widgets on the page in a hierarchical structure, so you can see which widgets are sitting inside which, and so on and so forth. And finally, a preview of your GUI, which I must add in most cases is not a very accurate representation of things like sizes and things. Those will all have to be set separately, but it does give you a good layout of where things are going to be placed. So we're going to create an example now, and it's going to be a simple application that just counts up each time a button is pressed. Okay, so it's just a simple counter. And then we're going to have another button which presents us with a total box. So now we're going to switch into... I'm going to come out of the presentation. So I've already have Glade loaded here, and we are just going to go through now the quick steps of how we would create a simple GUI in Glade. So I have a new project here, and the first thing we're going to need is a window. And with Glade, what you need to do is you need to place things inside what they call containers. So at the moment, this is just one container. So if we put a box in here, a button for example, it fills the entire page. So we need to separate our window into what they call containers. So for this example, I'm going to use the vertical box here, which will present us with 3 containers. Okay, so now we can fit 3 widgets on this page. Now I might want to have 2 buttons down the bottom. So, and you can see if we look at the tree here of the hierarchy, that this H box down the bottom, which is the horizontal box, is contained inside the V box, which was the 3 rows which we created earlier. So that's our simple layout of what we're going to do. So now we need a few buttons. So the first button here is going to be the count button that we press when we want it to increment 1 on the counter. We're going to have a close button, and we're also going to have our total button. And then at the top, all we're going to have is a simple, this is what the application's called. So I'm going to put in another H box here so that we can put a little image or an icon. So I'm going to use the image one here. And you can choose any, it takes standard PNGs, but I think you can use other formats as well. I'm just going to go down and choose a stock item, and I'm going to choose just the plus symbol. Okay? And now in our last box, we need to put a label of what the application does. So here's our label box. Put the label widget in there. And I'm going to tick this one here, use markup, which uses a very simplified HTML type language. So if I want to write in bold, I can do that. So Mr. Count, whoops. Okay, and we now have our labels been created. So now we need to just go through and change the names of some of these buttons. So this button here is going to be our count button. We'll make this one our close button. Now for certain buttons you can use their built-in stock buttons. So they've created some buttons for you which have got icons and labels next to them. You can do this yourself, but using the stock ones is a lot easier. So if I choose in the properties window stock, I can then choose which stock button I want. So I'm going to choose the close button, and you can see it updates it and puts it all there for us. So the last one that we need to create now is our total button. So we've designed our GUI, and that's now, for this example, complete. What we need to do now is set up where the signals point to the references, so that then in Python we can then make those references point to the handlers, which are going to do the actual functions. So if I click on the count button here and go to the signals one, we can see these are the signals that are available. So there's a signal when it's been pressed, there's a signal when you release it, but in our case we're going to use signal clicked, and we're going to make that point to the handler, or the reference, sorry, on count. Okay, that's just a reference name. It can be anything. It doesn't necessarily have to be a name of a function which is present in your Python code. And we're going to do the same for these ones. So we need to create another one for this one, and this one is going to be on cancel. Whoops. And this one on total. So these are the button signals have been set up. Now the only thing that's left to do is we need to tell Python what to do. We need to have a signal handler present for what happens when somebody closes our GUI window. Because when the GUI window closes, that doesn't mean the end of the program for Python. That will carry on running. So we need to tell it to quit the program. So what we need to do is we need to tell it what to do when this is, and they call it destroyed. Okay? So we need to click on the window to select the entire GTK window. And then down here, there's a GTK object signal which is called destroy. And on that one, I'm going to use the on cancel again. So that's our GUI done and finished, and I've saved that example as example.glade. Most of the time Glade will use the extension .glade on its files. So that's sitting in my on my file system. So I'm going to get rid of those for a while. And let's just go back to here. So what have we done? We've created our main window, and within the Glade structure you can have several windows, but we've created just one for this example. We've set up the initial widgets that are going to be used, and we've tied the signals coming from the widget to handlers. Okay? And this is now where Python's going to come in. So what do we need to do in our Python program? Well, for a start we need to import Glade and the GTK libraries. And then I'm going to create a class which I'm going to call GUI. And then I need to assign these signal references to their respective handler functions. So once these signals have been generated, what should be done in that case? And finally, of course, we need to write our handler functions. So I'm just going to load up the file, and then we can have a quick run through of what actually is happening at each stage. Well, that's really it. That's the entire program for creating that application. And as you can see, it's not really that difficult, and it's not really very substantial. So if we go through, at the top we've got the libraries that we need to include, which is the PyGTK bindings, as we talked about earlier. We need to include the GTK and the Glade libraries, and I've included some others in there which I need, string and OS, and the G-object one, which I'll talk about in a second. So we created our initial class, which I called GUI, and there's our constructor there. And the constructor will basically set up the window and set up the application ready for use. In other languages, I don't know if any of you have used constructors. Basically, as soon as this happens down here, as soon as the class is created, this constructor is run. Okay, so it's run as soon as this is created. So we'll go through here. What happens is this calls the Glade library to load our example Glade file. Okay, so that's the one we saved earlier. And this is the business I was talking about with the dictionaries and the assigning of the references to the respective functions inside our Python program. So we can see the onCount one here. That's the reference we gave it. And now we have to tell it which function it should refer to within our Python program. We can see that one there, onCount. Okay? OnCancel, that one's slightly different. Instead of actually calling a specific function which we write, there is a stock function inside GTK which takes care of closing down everything that's needed. And that one's called GTK main quit. And then we have our total button. And this is the one which is going to present us with our little dialog box. Now, note that we haven't created the dialog box within Glade. All we created was our main window. So we're going to actually create the dialog box manually, which is often a much better way of doing things like dialog boxes. Things which are going to appear and disappear quickly and don't have much information and many widgets on them. It's often better to use the built-in methods to do that. This line here basically runs this dictionary and sets up our handlers for us. We've initialized a count variable there to be 0. And we are setting this win variable here to point to our main window. And this is the saying about the widgets. Each of our items that we had on that page with the Glade file, so we had our window, we had our HBox and our VBox, and then the buttons inside those. Each of those is a widget in itself, and it has its own methods, and it has its own functions, and its own variables. So what we're doing here for quick and easy reference is we're saying, I might want to access this window widget quite often, so I'm going to assign it to the variable win. And then here we're saying, within that variable win, I want you to show it on the screen. Okay? By default, it won't show it on the screen. You have to tell it to be present on the screen. If we run that program without that, it will just do nothing. We'll just get a blinking cursor. And then we've defined our two functions that we need for this one. OnCount, which is just, as you can see, a simple counter. It adds 1 to that value of count. And on the CLI in the background, it will actually print out, I've added 1 to the total. This is more for our debugging than anything else. Notice in the declaration of these functions, we have to put self, which is the class it resides in, and widget. And the reason why is that when the signal is generated and the handler is called, the handler does this great thing. It tells it which widget called or created the signal. Okay? So from that onCount, we can tell which button was pressed. Because we could, of course, have several buttons on the page which all did the same thing. And we wouldn't need to create separate functions for those. We'd just link them in the dictionary. But if we wanted to know which button had been pressed, we could pick that up from this widget variable that's passed. Notice in this example, I don't actually use it because I'm not interested in it. Finally, we need to create the total box, which pops up. So again, the declaration is the same as previous. And now we're using one of their built-in methods, which is the message dialog method. So we're setting that to be equal to dialog because we're going to need to use it later. And this block here is actually all one line spread over 3 lines. So it basically, we need to give it some parameters. The first one is the parent window, which is self.win, which we referenced up there. We need to tell it some types of what type of dialog box is this. So it's a modal box. It destroys when the parent is destroyed. Okay, so if we close the program behind, it closes the dialog box as well. We don't want the dialog box sitting there even though the main program's quit. What type of box is it? Well, it's an info box, and what that will do is that will change the little icon that comes up, be it a little triangle with an exclamation mark in or a little question mark, or that changes all that for us. And finally it says, what buttons do you want present on there? And there are built-in methods. There's buttons close, there's buttons yes, no. And the great thing about using this built-in method is there are functions in there to add more buttons in. So you just run dialog dot, I think it's add button, and you can tell it to add a cancel button in, or you can tell it to add a save later button in. And finally, we're going to set the markup. We've seen this markup we used before, to say what's present in the dialog box. What text do we want it to show? And all it's going to show is the count value, which we've been adding to one by one. And because in Python we need to convert it to a string first, otherwise it throws a wobbler. And finally then, all we need to do is to run the dialog box. Okay? So it creates the dialog box, but it doesn't actually display it on the screen or do anything until we tell it to run it. Once that's done, the answer, which is the reply from that, in other words, it's saying if anything is clicked in this window, if we get a reply from the dialog box, destroy the dialog box, because they've obviously finished with it. So let's run that example and see what happens. So as you can see, I was saying about the preview, it's not exact. These buttons are all obviously a lot smaller. It shrinks them all down to fit. You can change that around. You can put packing in and padding and various other bits and pieces. So let's give it a test and see if it works. Well, we can see that the debug message is working. It seems to be adding one to the total. And when we click on that box, sure enough, we get our total displayed. So that's a very basic example of how to build a graphical application in Glade. I just want to take it a little further and to show you how you would, for example, I mean, it's one thing which I think is really crucial to learn, is how to interrupt those signals. So what happens if they close the program and you want to say, oh, but you haven't saved it yet. Do you want to save this yet? By default, it will just destroy it. It will destroy the window and destroy everything in it. Well, we might not want that to happen. So we've made some slight modifications to the program. It's essentially the same, except I think you'll find all there is one line added here and an extra function. So this is the line that's the important one. Remember I said you can connect up signals manually instead of using this dictionary. Well, this is what we're doing here. And we're saying that whenever a delete event signal is generated, in other words, if we try to destroy our window, it starts to try and delete all the widgets that are inside. So it says whenever that happens, don't do it yet, run this function first. Okay? And you can see it's in reference to the window itself. So it's only when the main window is trying to close, before it does so, it says, I must run this function first. So let's just go down quickly and see what that function does. You can see this time that the prototype line for it has changed slightly. We now have an extra variable which is passed called event. And that actually says what event was generated. And in our case, we know it's going to be delete event. So this line here greys out the main application window. It sets everything inside it to false. So none of the widgets can be active. We present the user with a dialog box, much the same as this one. Are you sure that you want to quit? If they destroy that box, then we need to make sure that we set the window sensitive again. Otherwise, they're going to end up with a non-usable application. Everything's just going to be grayed out. And then we need to handle their responses. So we've run the dialog, and the responses come back -8 for one and -9 for the other. Basically, the return of this function says do you want to delete the event that just happened? So if someone tries to destroy the window, it's saying, right, I'm ready to destroy. Do you want me to continue destroying? So you have to return, yes, I want you to continue destroying, or no, I don't want you to continue destroying. Just ignore everything that happens. So if we run that example, hopefully, when we try to close, are you sure you want to quit? Notice the greying out, as I said there. If we didn't set that back to be true again, then the user wouldn't be able to do anything but close it. Are you sure you want to quit? No. Are you sure you want to quit? Yes. And it closes the program down. So that was what we did. We used an event handler to act as an interrupt. For example, are you sure you want to quit? And we're just going to go through quickly what that does. So the user clicks the button and the class tries to delete the big window widget. So the delete event signal is emitted, and this signal invokes the handler as we connected it to the onDelete event one. The handler then returns true or false, and if it returns true, any further handlers or methods are ignored, as this event is effectively deleted. It's like it never existed. However, if we return false, it lets the delete event happen. And so these is how it ties into our example program. There's the onDelete event. There's our dialog box. Do you want to quit? If it's false, the program quits. If it's true, the program continues. So what are the advanced topics? How can we extend this? Well, you can create your own widgets, which is something I must admit I haven't even looked into yet. I'm still fine with the ones that I've got. You can use drag and drop methods. I was working on an application a little while ago. It's an applet that sits up in the GNOME applet bar for converting files to a different format. So you drag a Word document up there, or you drag a thing, and it says, all right, I found you've got a Word document. What do you want to convert it to? Oh, a plain text file, please. You have different signals and handlers for dragging. And the one which is probably the bane of everyone's existence is the tree stores and list stores. For me, this was probably one of the hardest things to get my head around, was these tree stores and list stores. They're the things like in Glade, we saw the hierarchical list structures and things. And creating one of those, it's not extremely difficult, but just getting your head around the concepts that it uses, for me, was a bit of a challenge. So what resources are available? Well, the Python website itself is a fantastic resource. I've downloaded all the PDFs that they've got on there, and I've got them on my laptop for use, all day, every day. The PyGTK website is, again, probably the most comprehensive resource on what widget types are available, what their signals are, what properties they can have, and it's really easy to navigate. And again, you can download the whole thing as a tar, and I've got that on the machine as well. And the GNOME website, when you start getting into the inner workings of GTK, using things like goption and things like that, the GNOME website has got some fantastic documentation on there as well. So we went through why should we use Python. We went through the concepts of signals and handlers, the tools that we can use, Python, Glade, GTK and PyGTK. A simple example, and we extended that slightly to use the events. We talked about how we can extend this even further, what resources were available, and I suppose now it's time for any questions that you might have.
Okay, packages.
Yes.
If you want to use this sort of stuff on a distribution,
Yes.
Have you got a list of packages we need to look at?
The only package, from an Ubuntu point of view, the only package that you need to install is Glade-3. And that will give you the Glade interface designer. Everything else should be there already, because a lot of the Ubuntu applications use Python, GTK and PyGTK. For example, the update manager, that uses Python and GTK and Glade.
mentioned for the dialog boxes you found it easy to do it in Python, is that because they're short and
Yes.
getting all the way into Glade just don't overkill?
Yeah, it is. It's, as you say, you could create all your widgets in there, but it's been created for a reason, and the reason is it's just a heck of a lot easier just to use their built-in functions.
What version of Glade do you mean? Or what version of Glade were you using there?
I was using Glade 3, but you could do the same with Glade 2. I haven't used Glade 1, but Glade 2 I've used, and 3 is fine.
So I was just playing around with Glade 2 on it here while you were talking and following as you were going. I couldn't find an option for outputting in Python.
For
outputting anything to do with Python. It supports C and C++ and Ada.
oh right.
Apparently not Python.
I think that it just saves it as a standard Glade file, and then that Glade file it does generate the source for C or C++, but you don't need that for Python. That's all handled by PyGTK. So you just save the Glade file, which is just the XML structure, and then the one that we had here, right at the top, this GTK Glade XML, that just reads in that Glade file and passes it all for you.
Could you make that an example available to us to look at?
Yeah, I'll give it to Tony, or he'll put it on the wiki. Yeah, no problem.
What about performance? Python apps can be a bit sluggish at times, don't they?
I've heard that. I talked to some of the Python guys on the IRC a little while ago when I was thinking, should I go down the Python route or start learning C or C++? And they said pretty much it can do anything that you want it to do. There are slight, performance increases with using things like C. I mean, obviously it goes through a separate binding, so it's going to be slightly slower. But for most applications, that I've used it for, especially for creating simple, GUIs just to do standard tasks that you do a lot, it's really easy to use. And the performance thing, for me, hasn't really been an issue. But it does slow down with larger applications. Also, I've heard.
Have you got involved using it across the network, or doing any network code at all?
I've done across a kind of virtual network. I worked on student control panel in Edubuntu, but for that we used dbus. So although we've got these terminal services connecting to one server, it's not actually across a network because they're all running it kind of on the same machine. So no, I haven't used it in a network per se.
If you have a program that's which is one or two windows doing things at the same time, them on mobile dial boxes or one things going is that a problem? Or?
It's not a problem. You do have to use some tricks, and I was working on one last night where you have to use those tricks. By default, as you're running through the program, once it's hit where it's doing a specific function, it won't go any further until that's finished. So what you create is these things called G-object timers, and you basically say, start this now, and I want to run this every 500 milliseconds. So you can have polling functions. For example, if you're doing a progress bar I did a progress bar for downloading. So it's downloading the file, and whilst it's doing that, it won't do anything else. So you add this G-object timer, and that constantly polls the output of the process and says, has it finished yet? No. Has it finished yet? No. Update the progress bar and do a little pulsey. So yeah, you can fake it, and you can use threads and things, which I've only just delved into.